The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome to today's webinar. Today's webinar is Common Methods for Testing. A quick round of introduction here. I'm the presenter, Bashan Patel. I'm an applications engineer here at Associated Research. Joining us today as a panelist is Syed Abidi. He's an applications engineer too. And also Alison Oba. She will be the organizer for this webinar. Before we get started, a couple of quick notes about GoToMeeting or GoToWebinar. Please use the question and answer utility if you have any questions about the material that's being presented. The questions will be answered live by Syed Abidi. If you have any issues with the video or the audio of this presentation, please contact Alison Oba using the chat box. As our previous webinar, this webinar will be also recorded and will be archived on our website. And if you'd like to have a copy of this presentation, please email Alison Oba. Her email address is allison.oba@arisafety.com. Just want to recap real quick what we covered in the previous webinar. We looked at what was ground. We looked at how to perform a ground bond test and how to perform a ground continuity test. We did a quick comparison. Also, we compared and contrasted the ground bond versus ground continuity testing. For today's webinar, we're going to be taking a quick look again at commonly performed electrical safety testing. This test includes ground continuity test, ground bond test, dielectric voltage withstand test. It's also known as the Hipot test. We'll be also looking at insulation resistant test, also known as an IR test. While I'm going through these tests, I'll be also showing you some of the common considerations and also videos to show you a proper way to perform the both test. We'll also take a look at some of the common issues that you might run into when you're performing electrical safety tests. Issues like how to set up test parameters properly. Also, we'll go over some of the messages or failure messages that you might encounter when you're performing the safety testing. The messages might include a breakdown message, high limit, low limit failures, or also an arc failure. And we'll also go over some of the quick things you could make sure that you have run a test successfully. At last, we'll cover some of the recommended items for performing before the test is performed and also while performing the test. And we'll also take a look at some of the general items for safety while performing the safety tests. So why do we perform tests on our products? There's four main reasons why we perform electrical safety tests. First is the safety of the end user. You want to ensure that the product does not pose a hazard to the end user. Quality. You're able to detect workmanship defects or any kind of faulty components from being installed on your product. It's also cost control. You're able to identify any production line issues that you might have before the product is shipped to avoid any costly recalls. It's also liability issues. The manufacturer of the product is responsible to perform all the electrical safety tests. Before we get started, I have a quick poll question here. Today's question is going to ask you what kind of electrical safety tests you perform on your production line. So please, we'll appreciate your participation in the poll.
Hello all, thank you so much for participating in our poll today. It looks like everybody runs the full gamut of electrical safety tests on their production line. We have 30% of people who perform ground bond tests, 39% of people who perform ground continuity tests, 87% perform Hipot tests, and 39% perform insulation resistance tests. Thank you so much for participating.
Okay, thanks for participating. Let's quickly take a look at the common safety tests that you perform on your production line. Let's first take a look at ground continuity test. A ground continuity test is a simple test to verify a ground connection exists for your a product under test. This is a test that's performed at a low voltage and low amp. It's as simple as having a continuity between two points. This is recommended to be a 100% production line test on class 1 products. I see that some of you answered a continuity test is only performed by 39% of the participant in the poll. Some of you might have a class 2 product that does not have the ground pin. For the people that have the class 1 product that has the ground pin on your power cord are required to run a 100% production line test according to your safety agency standards. We have a quick video here to show you how to perform a ground continuity test. Let's quickly take a look at a setup here. We have a device under test, which is a class 1 product that has the ground pin, as you can see. For this test, we're going to be using the adapter box here. So the adapter box is what makes a connection for the ground pin, and the return is connected to product chassis point. So this will be connected to the back of the instrument or any other chassis points. A low voltage signal is applied on the ground pin, and the return is taken on the return point on the chassis. We have a test setup here, a quick 1-second test with a 1,000 ohm limit. This will do a quick test of a quick continuity test between the continuity checkpoint and the return point. This example shows how to use an adapter box to perform a continuity test. As you can see in the results, the resistance of the ground path was 0.292 ohms, and this was a quick 1-second test. Let's take a look at a condition where a continuity test could fail. If your standards require the continuity to be within a certain limits, you would set your limits as this test is set up for 0.200 ohms, so 200 milliohms. A continuity run, we'll run a continuity test on this product. As you can see, this product failed a max limit failure. What this means is the continuity exceeded the amount set in your tester, which was set at 200 milliohms. Next, we're going to quickly take a look at ground bond test. I know this was covered previously. A ground bond test is a more strenuous test between a ground continuity. Comparing it to ground continuity, you're actually testing the integrity of your ground circuit. A high current is injected on your ground pin. The return is taken on the chassis, just like the ground continuity test. But in this case, the high current is what's stressing the cable, the ground circuit itself. Let's take a quick look at the ground bond circuit. As you can see on the left side is our ground bond tester that will provide the high current necessary for this test. The current is injected onto the ground pin, and the return is taken on the chassis point of the product. There's going to be some kind of impedance of this ground circuit, and the impedance should be set by the safety agency standards. This impedance could vary anywhere from 100 milliohms to 200 milliohms. Let's take a look at a pass condition for a ground bond test. During a ground bond test, the high current is injected and the return is taken on the chassis point. The pass indicates that the ground circuit was capable of handling the fault current and also stayed within the limitation for the impedance. So there was low impedance path to ground for the high current. A ground bond failures could indicate two things. Either the ground is not present or the ground that is present has a high impedance to ground. We prefer to have a low impedance circuit to ground, as if somebody comes in contact with the DUT, the current does not take the path to the person touching the DUT. This is a safety measure, so let's take a look at how the connections are made for a ground bond test with no adapter box. Connection 1 is your return lead connected to the high-M tester. Connection 2 is your product. On the left, you'll see number 3, the red current lead that's where the high current is outputted from the tester. The high current is injected onto the ground pin of your product. The reading for a ground bond test is usually in the milliohm range. This reading tells you if the ground circuit has a low impedance path to ground. Before we get into the next video, I want to take a quick poll here. This poll asks you a question about offsets. It's a really important feature when you're using ground bond tests, also for Hipot test. So please take a moment and participate in the poll.
Hi, Bashan. So thank you all for participating in whether or not you use the Hipot or ground bond offset feature. It appears that a little bit more than 50% of people use the offset feature, 20% of people use the Hipot offset, only about 12% use the ground bond feature, 32% use both the Hipot and the ground bond offset feature, and 36% of people do not use the offset feature at all. Thank you so much for participating.
Okay, thank you for the participation. So let's take a look at a quick video of how to perform an offset. The reason we perform offset on ground bond tests is you have your test leads, which are considered part of the ground circuit. You want to offset this test lead resistance, and this is done by using the offset feature on our ground bond testers. Here we have a Associated Research 3140 ground bond tester. The test is set up for a 25 amp test. You have your high current lead and the black return leads shorted together. This is how you perform an offset for the resistance of the test leads. What we could do is the ground bond tester will perform a quick test to determine the resistance of the test leads. Since the leads are shorted, the auto offset, or the tester will actually read the resistance of the leads. As you can see, 1 milliohm of resistance is what's the test leads resistant. This will be subtracted from your reading for your ground bond test. Again, quick look at actual performing of a ground bond test. High current is injected onto the ground pin, and the return is taken at the chassis point of your product. We'll do a quick ground bond test on this product. It's a LED light. And this one we have a high limit set to 100 milliohms. As you can see, the 1 second quick pass of the ground bond and the lead resistance, or the ground resistance for this, the product was 56 milliohm. Next, let's take a look at what would result in a failure. If your test parameters were set properly according to the standards, and if the standards required you to have 50 milliohm of resistance, you would enter the parameters into the tester, and any resistance seen higher than 50 milliohms will result as a fail condition on your tester. As you can see, the result is a max fail, meaning 25 amps of current was applied to this product, but the resistance to ground, or the resistance of the ground circuit, exceeded the limit that was set, which was 50 milliohms. This was a quick example of how a ground bond test is ran and what the results look like for both the pass and the fail. Let's take a look into some consideration of why when performing ground bond and ground continuity tests. A ground continuity test just verifies the connection exists. As little as one strand of wire could indicate a pass result for your ground continuity. This does not mean that this circuit will be capable of handling any fault current. A ground bond test is a high current test compared to a ground continuity, which is a very low amp test. Your test parameters depend on the safety agency standards. For example, UL 60335-1 for your household appliances recommend that 1.5 times the rated current of the product or 25 amps, whichever end is higher. So we want to make sure the product is tested properly, and in this case, if you had a product that had a amp rating of 10 amps, 1.5 would be only 15 amps current. So the ground mount test current for this case would be 15 amps. Since there's a stipulation that you will need to do a higher condition between the rated current and the 25 amps, the ground mount test should be ran at 25 amps. We talked about test lead resistance. I see that not a lot of people use the offset feature. It might be a case where the resistance is low enough for you to not have to use the offset feature, but people that use any kind of test fixtures or any kind of a test setup where the lead resistance accounts for a majority of their connections, majority of their ground circuit, the offset feature is used to negate this resistance. Another method to negate this resistance is called a Kelvin method. This is a 4-probe system where the high current is injected onto the 2 probes, and the 2 other probes measure the actual resistance of the ground circuit. It is always important to run a ground bond test before running any Hipot test. The reason for this is if you had a Hipot failure, you want to make sure there's a ground circuit available for the Hipot test fault currents to run. So you always want to make sure either the ground bond test is ran before or during a Hipot test. We're moving on to dielectric voltage withstand test. This is also known as a Hipot test. This is one of the most commonly performed electrical safety tests on products. The Hipot test is used to determine the insulation product, determine whether the insulation of the product is able to withstand over voltage condition for a period of time without breaking down. What this means is that we apply high voltage between the line neutral shorted to ground, and we're measuring the insulation between the insulation material that's between this current carrying conductors and the ground circuit. Measuring at high voltage for a short period of time ensures that during the normal operating voltage, the product will be able to withstand any small voltage over voltage conditions. Quickly take a look at the Hipot test circuit diagram. We have our Omnia tester on the left. The high voltage is outputted at the red connection, and the product circuit diagram on the right will show you line neutral are shorted since we're applying high voltage to both the line and neutral at the same time. The returns taken onto the on the ground or the chassis point of the product, we're measuring the leakage current that is generated between this capacitor that we just created. Let's take a look at a pass condition. Of what Hipot test pass condition indicates that there is no breakdown of this insulation. The insulation has all electrical unit instruments will have some kind of leakage, but this leakage measurement is within allowed limits. Some of the safety standards only call out for breakdown. A breakdown is an actual breakdown of the insulation where the leakage current exceeds the normal leakage current. It's also called a catastrophic breakdown or catastrophic flow of the current. This is what happens when you have a fail condition. So when you apply high voltage to your product, if there was any breakdown of the insulation material, the current flow will be much higher than your normal leakage current, and this will indicate as a fail on your Hipot tester. A quick look at a class 1 product, how the connection is set up. The line neutrals are shorted together and high voltage is applied to the line neutral, and the returns taken at the chassis point of the product. We're measuring the leakage current to make sure the leakage current does not exceed a certain set amount, or there's no breakdown failure. A breakdown failure would be exceeding the measuring capacity of the instrument. Most of the results that are displayed for a breakdown or actually a Hipot test are in the milliohm or microamp range. We're going to take a look at the Hipot video here. This is the how to perform the Hipot test. Thing to note here, we have the same setup. The connections are made the same way as a ground continuity test. The similarity between a ground continuity and a Hipot test is that the connection made are used to the similar setup is used to do a Hipot test. On this test, we're going to be taking the return on the return points as our ground continuity test, and then we're going to be applying line neutral are shorted in the adapter box itself, which is connected to our instrument running a Hipot test. We're going to run a Hipot test at 1240 volts. Our high limit for leakage current is set to 10 milliamp, and we'll do a quick 1 second test as is on production line. As you can see, the product leakage is 0.589 milliamp. So this product is leaking anywhere from it's leaking right now 0.5 milliamp of current. Let's take a look at a fail condition where this product would exceed a limit that's set in your instrument. The resulting will be a high limit failure. What a high limit failure is tells you that the product that you're testing exceeded the limit that you set in your tester. In this case, our limit was set at 0.5 milliamp, and the product leakage was higher than that, resulting in a high limit failure. Next, we're going to take a look at a product that is not connected to a line cord. This product is a heating element. You might run across elements, a product that does not contain a line cord. For this one, we're testing the insulation that's between the heating element compared to the outer shell. We're applying high voltage to the input where the voltage, the line current carrying conductors, and we're taking the return on the product chassis point. Let's take a look at the parameters here. For this test, we're going to run the test at a higher voltage. We're running at a 2000 volt test, and we want to see what kind of leakage current does this product have. So this product has 0.190 milliamp of current, leakage current, when running a 2000 volt test. If this product was to break down, you will see a breakdown message appear here, and a current exceeding 30 milliamp, which is the measuring, which is the limitation of the instrument itself. So any sudden spikes in current would indicate a breakdown failure. Let's take a look at some consideration when performing a Hipot test. Some of this comes from the safety agency standards. If the test voltage is not specified in your agency standards, there's a good rule of thumb that says the input voltage multiplied by 2 and then adding 1000 volts to it. So a normal product that operates at 120 volts, you multiply that by 2 and add 1000 volts, come up with 1240 as a test voltage parameters. For your production line test, it's a 1 second test, and if you're doing any kind of design test or type testing, it's a 60 second Hipot test. You're checking for breakdown conditions or any kind of leakage current that exceeds the limit that's set in your safety agency standards. If you don't have any leakage current specified in the standards, you could use a rule known as a known good product rule. You want to take the product that does not have any breakdowns, take the product and measure the leakage current. Take this sample leakage current and add either 25% plus or minus to get your high and low limits of your leakage current. So any product that comes down the line that exceeds this nominal leakage current, you know either something is wrong with the product itself or there's something that's not connected. If the product is failing low limits test, this indicates that the connections are not made properly. The reason you want to set low limits on your Hipot test is cases where a test lead falls off of the DUT or a test lead is not connected properly. A low limit failure will actually indicate a low limit failure, indicating that a product is not connected to the test leads. Let's take a look at some of the other components that might be installed in your product, things known as filtering capacitors or transient suppressors. This would cause you to have these components will cause you to false fail your product, as they're there to suppress any kind of transient voltage. Most of the standards would exempt you from allow you to remove the transients and then perform the Hipot test further down the line. Another thing we run into all the time is also making sure the on-off switch is turned on for your DUT, performing an AC/DC or also an IR test, which is you want to make sure you have your the products turned on. Let's take a look at the three different kind of failure messages you might see on a Hipot tester. A breakdown failure would indicate a really high current that's flowing through the insulation of the product. This is usually beyond the measuring capacity of the instrument and also indicates there's an arcing condition. An arcing condition is what happens when you have an arc condition happens when you have a high frequency current riding on a low frequency current wave. What this means is that there's a high frequency component to all of your leakage current, and if this ever happens, the arc failure detector will go off on the Hipot tester. This does not indicate a breakdown, but it's perceived to be preceding a breakdown. So any arcing should be looked at as a quality issue. Then you have your normal high limit, low limit. The high limit and low limits are set by either the standards or internal requirements. Let's take a look at insulation resistance test. What an insulation resistance test does, it provides the manufacturer with a quantifiable value of the resistance value of the product's insulation. This is the same test performed as an Hipot test. All the leads are connected the same way as a Hipot test. The leakage current is used to measure the resistance of your insulation. This usually is a DC test. So a DC voltage is applied between line neutral shorted and the returns taken onto the chassis point. And the resulting number will result in the insulation resistance of your product. Take a look at a circuit diagram for insulation resistance test. Again, this is same hookup as the Hipot test, where you have your line neutral shorted and return taken on the chassis point. What insulation resistance does is actually measuring the leakage current, and in turn gives you the actual resistance reading. We have a quick video to show you how to perform a IR test or insulation resistance test. Again, the DUT, which is device under test, is connected. Line cord is plugged into the adapter box. Returns taken at the chassis point. And now we're going to set up a test to perform a 1000 volt IR test. As you can see, the result is a pass, and this is a limit. The insulation resistor for this product was 6,700 mega ohms. For this case, the higher the reading for resistance is, the better the insulation of the product. For an IR test, the most important parameter would be your low limit. You want to make sure your product is higher than the low limit that's set on your product. Let's quickly look at a test that would fail an IR test. If you have set the low limit properly, for this case we have set 10,000 mega ohms. If the product never reaches 10,000 mega ohm, it will result in a low limit failure. So an important thing to remember about a IR test is that the low limit is the most important number. The higher the IR reading, the better the product's insulation is. Some consideration for running an IR test. You want to make sure you allow enough time for the IR test to run to get some adequate measurements, anywhere from a minute to up to 10 minutes for a stable reading. Since this is a DC test, you want to make sure you are ramping up the voltage. What the ramp up does is applies the voltage over a period of time. In a DC test, this will avoid any false failure. Again, the most important parameter for IR test will be your low limit set, which will want to ensure that the product meets a minimum requirement of your safety standards. Insulation resistance usually specified at least 1 mega ohm of IR at a 1,000 volt test. Next, we're going to take a look at some of the recommendations that we here at Associated Research make while performing testing or before performing testing. You want to make sure the high voltage output is off before making any connections. Our testers have a indicator on the front of the instrument that indicates if the high voltage outputs are active or not. You want to make sure this this indicator is not indicating any high voltage on the outputs before making any connections. Visually inspect the test leads for signs of any excessive wear. If you see any excessive wear and tear on your leads, please replace the leads. You want to always make sure you connect the low side of the tester to your device under test first. This ensures that if the device is energized, it will be quickly de-energized when you are hooking it up to the return side. You want to make sure that the alligator clips are securely clipped onto the metal part of the DUT. In an event that the alligator clips don't come off and cause a hazard situation. When using a test fixtures, you want to make sure the fixture has all the proper guards in place. This is when you're applying any kind of protective measurements when you're performing Hipot test. You want to make sure all your protective measurements are in place before running the test. You do want to double check all the connections, make sure the proper connections are made. Making the wrong connection could damage the DUT or the tester itself. Making a wrong connection could also jeopardize the operator testing the product. You want to also double check the tester settings. You want to make sure that the voltage that's being applied is the proper voltage for the product that's tested. You want to make sure you don't damage the product or apply any higher voltage than is necessary for the product in the test. During testing, you want to make sure you're not handling any, you're not touching the DUT that's under test. You want to make sure if you do handle any of the wirings, you want to make sure you're using the insulating material while you're handling the test leads. You also want to make sure the test leads are close to the DUT as possible, as close to the DUT as possible. You want to avoid any unnecessary crossing of the test leads. Also want to make sure no one ever touches the cabling of the Hipot test or any connection for the DUT. When you're doing a DC Hipot test, it's always important to remember that you're charging up a product is being tested. It will be charged up. In an event that a lead comes off, you want to have what's called a hot stick. This is a device that allows you to discharge any product that's been charged up. It has one connection to ground, and the other connection has a metal connection that could attach to the DUT if necessary. After the test, you want to make sure you turn off the high voltage or the actual tester is turned off, and also want to make sure you discharge any of the DC product that was being tested. Here's a quick take a look at things not to do while performing test. We do get, once in a while, we'll have inquiries come in about what to do about the test leads. You don't never want to play around with the test leads. You always want to make sure the test leads are on your testing bench all the time. No ESD smugs. Since the Hipot tests are not, it's the opposite of your ESD. You want to make sure you don't want to be grounded. So ESD smugs should not be allowed in a Hipot test area. Of course, checks to see if the ground pin is never disconnect the ground pin of either the tester or the DOT, as this is what provides the safety for your product that's being tested, also for the product that also for the tester. You want to make sure you never. So that concludes our webinar for today, but there is one more little note here. If you want a copy of our audit survival guide, you could see the link that's provided in the chat box. We have some documentation that provide you some document that provides you easy ways to ensure that you're properly complying with your audits. And please take a look at the link that's provided in the chat box. Here's some contact information. If you like a copy of this presentation, please contact Allison Oba at her email address at allison.oba@arisafety.com. And I'll open up the floor for any questions that anyone might have.
Hey, Bishan.
Yes, Syed.
So we have a question that I think will be great if you can address it to the entire audience, is just kind of quickly go over a recap of the differences between Hipot and the insulation resistance test and how it's similar more to the DC Hipot, something along those lines.
Sure. Right, so if you take a look at the insulation resistance test, you have your line neutral shorted, which are your current carrying conductors, and the ground is taken at the return point of your product. Doing a Hipot test, you're applying high voltage and then measuring the leakage current. What you're measuring for a Hipot test is you want to make sure that there's no breakdown occurring. For an insulation resistance test, the same circuit is used, but in this point, in the insulation resistance, you're actually getting the quantifiable value of the insulation that's protecting the line, like current carrying conductors versus ground. So during a Hipot test, you're looking for any kind of breakdown or any high leakage current happening through the insulation. Doing an IR test, you're actually getting a quantifiable value of this resistance. If that answers the questions, if you still have any questions, please let us know.
Hi, Bishan. I think a good question would be if you were to go over the offset feature again, what it is and why it's beneficial to use it.
Sure. So let's quickly take a look at the offset feature on a ground bond test. Since you have the leads, the testing leads, as a Hipot tester, it sees the testing lead as the resistance to ground. If you had a very long cable or if your connections were long, the resistance of your test leads are added onto the ground bond test itself, because the ground bond tester sees the leads at the output of the tester itself. For your safety agency standard, you actually want to test the impedance from your ground pin to the product chassis. So what you want to do in this case is offset the impedance or the resistance that is on the test leads, and that's the reason you use the offset feature on the ground bond test. There's also an offset feature on the AC Hipot test. The AC Hipot test will offset the internal leakage of the tester itself. So when we say offset on AC Hipot test, you have an open circuit connection with the wires connected. So let's take a look at so a diagram like this where a Hipot test is being ran. The testing cables itself would have some kind of leakage current, and also the internal mechanics of the instrument itself would have some leakage current itself. So on a offset for the leakage current. This offset comes handy for DUT that really have high either high resistance to ground or really high leakage current. You want to make sure you offset anything that's not considered part of the DUT. So the reason for using the offset feature is that you are testing the product from the actual line cord or the connection point of the product to the ground chassis, and not including any cabling that might be included as part of your test fixtures.
Hey, Bishan, one more question that came up is that is there a tester for all the tests, or each tester can only test one, like the Hipot and the IR using one tester or different tester? Can you just kind of go over the different combinations that a tester can have in terms of the type of tests it can perform?
Okay, so let's quickly take a look here. Let me see if I... So there are testers out there that will perform all of your safety tests at the same time. In the picture you see here is our Omnia tester, Omnia 2, 8200 series tester. This tester could perform a ground continuity test, a ground bond test. It could perform an AC Hipot test, a DC Hipot test. It could also perform an IR test, and there's also a leakage test it could perform. So this is our this model will perform all your safety tests in one. There's models that AR has that also perform just your Hipot test, a continuity test, and also an IR test, whether it be AC or DC test, DC Hipot test. A ground bond, since it needs a high current, it's usually a separate tester by itself. The reason for this is the ground bond tester needs its own transformer to generate the high amp current, and the units that we currently have this is an all-in-one unit, but we also make units that do only the ground bond test, and there were units that we make that all do the continuity Hipot, which is AC Hipot, DC Hipot. And since we're doing a DC Hipot test, any of the instrument that could do DC Hipot are also able to do IR test. Any of the instrument that could do Hipot test are able to do IR test, since it's the same test, just getting the quantifiable value in return.
Sean, one more thing. So if you can kind of, going back to the similarities and differences between IR and Hipot tests, can you kind of go over how the insulation resistance test is similar in nature to the DC Hipot test, and how are the voltages different?
Sure. So taking a look at our IR test, so if you take a look at our insulation resistance test, it's similar to a DC Hipot test, because you're applying a DC voltage between your line and neutral, and you're measuring the resulting leakage current that's actually flowing through the insulation itself. During a DC Hipot test, you're in a DC test, you actually have the real current that's flowing through the insulation resistance. So a similarity between a DC Hipot test and IR test would be that you're actually measuring the leakage current that's actually flowing through the insulation barrier between the current carrying conductor and the ground circuit.
Hey, Bishan. One more thing that came up is in terms of Hipot and the insulation resistance test, more talking towards the class 2 type products. So is there a ground pin connection necessary with the Hipot test, but is it needed with the IR test as well or not? Or can how would you do a Hipot or a IR test on a class 2 product that does not have a grounding circuit?
Sure. For a class 2 product that does not have a grounding circuit, you would want to simulate the return would be simulating using either an aluminum foil or some kind of conductive connection. So you would what do you want to do is have some kind of either an aluminum foil or conductive path for the return current. Let's take, for example, if you have your laptop, which is mostly plastic all around, and if you wanted to measure the AC Hipot test on your laptop, you would place of aluminum foil over either the keyboard and then hook up your return leads to the actual aluminum foil. This will cause any leakage current that goes through the insulation to flow through the aluminum foil back to the return of the instrument. For class 2 products, there's definitely different ways of testing Hipot test. You would want to make sure there's some kind of conductive path on the outside of your product itself that would allow it to read some leakage current through the insulation itself. Since class 2 products are doubly insulated, they do not require a ground circuit since protection is provided by the dual insulation, but you still want to perform an AC Hipot test and also an IR. So the IR reading for a class 2 products will be similar in nature, where you're reading the actual current that flows through the dual insulation onto the external conductor, which could be aluminum foil wrapped around the wire. And in this case, the insulation resistance turns the leakage reading into an actual ohm reading for the insulation resistance.
All right, Bishan, it looks like we are about done with answering questions right now. If anybody has any other questions, feel free to still send them, and we can message you through chat. Anyway, thank you all for attending, and have a great week. Bye.